Non-complex numbers, well, everything is a complex number. You just have a real portion of it, or you have a imaginary pool, which is considered the full complex number.
One's not very complex.
1 is a real part of the complex number. By the end of today, you'll see how that breaks out.
Well, why is it complex numbers and just not numbers?
What's that?
Why is it complex numbers and not just numbers?
Because someone just gave that a definition. They are numbers, but in general, they're a complex number. Because it's not just a simple number. There's other things that go with it that makes it complex. Does that help? Okay. All right. Where did I get the radical? To get the x squared, I had to take a square root of both sides. Does that make sense? Because I had x squared equals negative 24, so I had x squared equals negative 24, and I want to get x by itself, so I take the square root of both sides. Is that what you were asking? Okay. Does that answer your question? Okay. Yeah. Because I have here. Okay, 24. So 24. So you're basically going to try and solve for the x, and then you're going to do the I. Get it? Try the other one. Yeah, try that. It's rock.
I have 2 questions.
Okay. That is correct? Nope. That's correct. You're good.
I have 1 more.
Oh, yeah.
I think I'm not sure.
You know, it doesn't matter which one you do, because eventually you'll get down to what you need to pull out. So if I did, let's say 14 and 2, right? I would do, so if I have 28 and I do 14 and 2, this can be 7 and 2. So now I know I have 2 2s, and I can pull that out. If I have a pair, so when you have a square root, the index tells you how many you need to pull one out, right?
Okay.
So it tells me I need 2, so I have 2 of the 2s, so I can pull one of those out. So I have 2 square root of 7, right? So if I do it that way, if I do the square root of 28 and I do, what's another one that is there another one that we could do for that? 7 and 4, 7 and 4, right. So I could do 2 and 2. Again, I need 2 to pull one out, and so I'll be left with 2 square root of 7.
Okay.
So no matter which way you do it, you eventually get down to where you can get to the very bottom.
Okay.
Does that help?
Yeah.
I just didn't.
Oh, you like that number again?
Yep, that's perfect. Can you try that way? All right, as you guys are waiting, if you want to flip the page, there's a few examples on the top, 1 through 5, that you could practice with as well. Actually, this is the part that everyone started yelling at me at. Go ahead and try the ones on the other. They're a little bit simpler, but just get some extra practice. 1 through 5 on the top of the second page, imaginary numbers. They can pull it right, so it's going to be 4, so you pull those out. Yeah. Yep. I'm sorry. You got it. Okay, so now you have 6. You can break that down into 2 or equal those. Right? And now you need 2 kinds. You have 2 3s. So those 2 3s can get 4 out to be 1.
So
You have 3 I.
3 I.
Third. So basically the index tells you like a pair.
Oh, so you just break down one.
You just keep going down so you can't break down anymore.
Okay.
And then you go through and find your pairs. If it was like cube, then you go find your 3 of a kind, and then you can pull that 1 out for that 3 of a kind. All right, I'm going to go ahead and go over this, you guys. If you haven't gotten there, then... Yes.
I have a question.
4. Did we get I? Okay, for 5, did we get -1? Oh wait, let me see. Maybe I got this one wrong. Hold on. I think I did this one. 65 divided by 4. Yeah, it's I. Sorry, I. And then for 43, did you get -I?
Yes.
Okay. All right. So if you are good with dividing by 4 and looking at remainder and looking up here, you're good. However, there is another way you can do it. It's up to you. And you have that description kind of right here. Okay? If you, like, basically what you're looking at is how many, this is like 0 spots from like if I'm 4th, right? I'm 4. I'm at 4. If I'm at a 1, I'm 3 spots from, or 1 spot from a 4. If I'm a 2, I'm 2 spots from 4, and I'm at a 3, I'm 3 spots from 4. So if I have, let's say, I to the 7, which is right here, okay, I could find my nearest multiple of 4, which is 4, right, and I could subtract it from there, and I'm going to get a remainder of 3, right? So on the 1062 that I use, if you see that, is it 1060 is the nearest multiple of 4, you could subtract 1062 from 1060 and get 2, and then you're going to fall underneath this one here. So that's when you look at the exponent.
Well, the way that we did it always worked.
Yes.
So we just do that.
Yes. Some people like the subtracting of it from the nearest multiple of 4, and then seeing the remainder, and that falls right here. Some people like dividing and looking at the remainder. Okay, so that's completely your preference. It's how far from that 4 value are you that you would look at the exponents then. Okay? Does that make sense? Alright, so let's try, so why does this matter to us? We just tried these here. Well, how this works is, what we're going to do then is, notice we have multiple terms on the bottom here. We're going to solve these terms, and then we're going to simplify using these values up here. Okay, so let's look at the first one here. If we have negative 4i times 5i, okay, I have 4 times 5. So if it were like negative 4x times 5x, it would be negative 20x squared, right? So we're going to do the same thing. The i's are like variables. You multiply them together like you would. So I'm going to have negative 20i squared, right? Well, because I squared is actually a value, I want to then find what that value is. So you'll never have an answer with an I with an exponent. Because if it's a squared, you're going to find the value of what that I equals. If it's cubed, you're going to find the value of what it equals. Like, you're going to find the value. So what does I squared actually equal?
-1.
It equals negative 1, so that's really negative 20 times a negative 1, which equals 20. So if your answer has an I of an exponent other than 1, you need to simplify more.
This is good.
Okay? Alright, so now let's try, you all good with that one? Let's try the next one. Now this one here, if you have a square root of a negative number, get the i's out first. So the first thing we want to do is make those I square roots of 15 times I square root of 6. Okay? The rule of multiplying is I take the I and I multiply them together, right? So I'm going to have I squared. And then I'm going to have the square root of 15 times the square root of 6, which is the square root of 90. Okay? So the square root of 90, I'm just going to do it up here because I have no room. Square root of 90 can be broken down into 9 and 10. So that's a 3 square roots of 10. Okay, so the square root of 90 is 3 square roots of 10. So I have I squared, 3 square roots of 10. Well, what is I squared? Negative 1. Again, if I have an I other than to the 1 power, I want to find the simplified version. So it's negative 1 times 3 square roots of 10. So that's going to equal, I'm sorry, I'm kind of going in a circle here. That's going to equal negative 3 square roots of 10. So you guys see how I kind of snaked around there? Right here?
Yeah.
Negative 3 square roots of 10.
Okay.
Yeah. Sorry, it's really...
Why is that negative 3?
So, you're good with how I got I squared square root of 90?
Yeah.
Okay. Square root of 90 breaks down to 3 square roots of 10. Because it's the square root of 9 times the square root of 10. Square root of 9 is 3. So 3 square roots of 10, so that's that. And then I squared. Right? I squared equals negative 1. So I have negative 1 times 3, so that becomes negative 3 square roots of 10. Okay? Go ahead and try 3 and 4 on your own. Try 3 and 4. 3 mimics 1, 4 mimics 2. Okay? Go ahead and try 3 and 4 on your own.